Today I'm gonna talk about the derivative of composite function, chain rule, trig function, part 3. First of all, let's recall the chain rule. The derivative of capital F, letter fx, equals the derivative of capital F, letter fx, times the derivative of letter fx. Okay, here the capital F can represent any trig functions. For example, if capital F is sine, then the derivative of f should be cosine. If capital F is cosine, then the derivative of capital F should be negative sine. If capital F is secant, then the derivative of capital F is going to be secant times tangent. Okay, I also list all the other derivatives that can be used for solving the following examples. So the second one is power rule. Derivative of x to the power n equals n times x to the power n minus 1. The third one is constant multiple rule. Derivative of a constant times fx equals the constant times the derivative of this function. I list all the derivatives for the all trig functions. There are 6 of them. Okay, now let's take a look at the first example. For the first example, we have sine cotangent x, so we can easily tell what is capital F, that is sine, and what is letter fx, that is cotangent x. Okay, so we're gonna follow this formula. Derivative of capital F gonna be cosine, right? Because here is sine, should be cosine. So we have cosine, and fx gonna be cotangent x, and times the derivative of fx, that is cotangent x prime. And now we can evaluate the derivative of cotangent x. That is what? That is negative cosecant x squared, right? So we have negative cosecant, okay, cosecant x squared, and of course we can simplify it. We can put it like that: negative cosine times cotangent x times cosecant x squared. Okay, now let's take a look at the second example. For the second example, we can tell the capital F is cosine. What is fx? Fx is this guy. Fx equals 2 sine x plus 3 cosine x. Now we're gonna follow the formula again. Capital F is cosine, so that means derivative of cosine should be negative sine. So negative sine fx is this guy, 2 sine x plus 3 cosine x, times the derivative of letter fx, that is here 2 sine x plus 3 cosine x. Now let's check the second term. For the second term, we know that's the derivative of sum of two functions. That means we're gonna do the derivative for each term. Okay, so we just need to copy the first term and 3 cosine x, and for the second term we do the derivative for each term. Okay, now for the first term, here we have constant. Okay, so we're gonna apply the constant multiple rule. So that means what? We're gonna have 2 times the derivative of sine x. For the second term, gonna be 3 times derivative of cosine x. Okay, we can simplify then. Negative sine 2 sine x plus 3 cosine x, and the 2 derivative of sine x is going to be cosine x, and the derivative of cosine x is going to be negative sine x. Negative sine x times 3, negative 3 sine x. Okay, that's it. Now let's take a look at the last example. For the last example, we can see the capital F is secant. Okay, is a secant. What is letter fx? That is 4 times tangent x plus 3x squared. So we can write down letter fx is 4 times tangent x plus 3x squared. Now we have what? We have derivative of capital F. Capital F is secant. That means secant times tangent. So we have secant and fx 4 tangent x plus 3x squared times tangent. We have 4 tangent x plus 3x squared, and also we have the derivative of fx. So times derivative of letter fx, that'll be 4 times tangent x plus 3x squared. Okay. Now, for the last term, we know that is the derivative of sum of two functions gonna be the derivative of each term, right? So we're gonna do the derivative for this guy, and we're gonna do the derivative for this guy. Let's copy the first two terms. This is secant 4 tangent x 3x squared tangent 4 tangent x 3x squared, and we're gonna do the derivative for each term. Okay, and now let's focus on these two terms. In the first term, we have 4 times tangent x. We're gonna follow the constant multiple rule. We're gonna keep the constant, and we do the derivative only for the tangent x. Similarly, 3x squared, we're gonna keep the constant 3 here and do the derivative only for the x squared. Now we can continue. Secant 4 tangent x plus 3x squared times tangent 4 tangent x plus 3x squared, and we have 4 derivative of tangent x gonna be secant x squared. Okay, secant x squared. And for the last term is derivative of x squared. So derivative of x squared gonna be power rule, right? Power rule. 3 times 2x to the power 2 minus 1. Now we can simplify it, and we're gonna get the final result. Okay, secant 4 tangent x plus 3x squared tangent 4 tangent x plus 3x squared, and 4 secant x squared plus 6x. That's it.